That's a great question. Gold star. You guys can split that one. What's your name? Emily. You're getting a gold star. Deal with it. Think of diffraction AM versus FM. Which one is longer wavelength? Which one is shorter wavelength? Tell your neighbor. Like 90% you didn't say a word. Either you have imaginary friends next to you, or what does AM and FM stand for? Anyways, AM, longer wavelength. AM bends more. AM you can hear from further away, or you can hear AM radio from further away, because AM will like bend more around mountains and not be absorbed by them as much as FM. FM cannot bend as much around mountains and trees and hills and big buildings and whatever. Okay. AM has a longer wavelength. That is true. FM has a shorter wavelength. So, we go to a question from the second midterm. Classical music, or music that requires a lot of nuanced whatever, wine for your ears. FM plays high quality music because FM has a faster frequency and can transmit more information per second, more bits per second, so the music can sound better than AM. So AM has a lower frequency, it can't transmit as many bits per second, and so the music coming out is lower quality. So there's the give and take. FM you get better sound, but it doesn't go as far. AM goes further, but you get worse sound quality. That's why usually AM is like talk radio that my dad listens to and then gripes about whatever. Never mind. Farther. AM in general you can hear from farther away. Because AM, longer wavelength, can spread more. So instead of hitting like a mountain and stopping, well, yeah. Instead of, it bends more around things and has like a longer... Okay, metal is a good conductor of heat. However, many thermos mugs are made of metal, and thermoses are supposedly insulating. They should keep the hot drinks hot. Why does this work? You have 30 seconds. Do you have a thermos on them? Do you have metal thermos with them? That's metal thermos. Is that metal? Sweet. But why? That's the question. Why are thermos? Why is this metal? So why is this thermos metal? There's a hint. There's like liquid in here. Yeah, totally. Well, yes. Yeah. Okay. Tight. Yeah. Match. Yeah. Match. Yeah, okay. No, like the reason this is ringing is because there's an outer thermos of metal and an inner thermos of metal, and in between the two, you have either vacuum or just air. Which one's a better conductor of heat and electricity, metal or air? I hope you said metal. Right? So yes, if this thing was just made of metal and I put a wicked hot drink in here, I'd burn my hand. However, if I have two thermoses, one side and another, and I put air in the middle, air is a bad conductor. The air or vacuum acts like insulation and doesn't let the heat escape. Cool? Thank you for whoever's ever this is. Can you just, like, old-timey firefighter bucket that thing that way? Why not make them out of plastic? I don't know, BPA lining and plastic leaching into your hot drink and giving you brain cancer or whatever. Although not substantiated by empirical evidence, I'm just saying. What's up? I mean, so, like, up top you can connect them with, like, plastic or something. Or, I mean, it doesn't really matter. If there's some disconnect between the two that's not metal, then, you know, there's no way for the heat to get from the inside metal to the outside metal. What's up? I mean, I'm sure they're probably, like, metal's probably more durable than plastic. Like, metal can't break like plastic can. That's also probably true. You can bend it, yeah. Yeah, maybe. If you could cheaply and quickly manufacture plastic into the shape of this thing, I don't know. Go for it. What's up? Same thing. So hot and cold is almost the same thing. A container that keeps something hot keeps the heat in, and something that keeps something cold keeps the heat out. It doesn't keep cold in, it keeps heat out. You can't keep cold places. All you can keep is not heat. What's up? Yeah, exactly right. Yeah. So if you live in like an old crappy house and you have the single pane windows, you have to like blast the heater because the cold air outside can just make the glass cold, and then that will that will leach heat out of your apartment. But if you have these double layered windows, it's a very good question. Double layered windows with air in the middle, the outside glass gets cold. The air in the middle is a bad conductor. It's a good insulator, and so the inside glass is not as cold, and so it doesn't suck out as much heat. What's up? Yeah, it has to heat up the inside. It has to heat up the metal thing on the inside, but that's like pretty negligible. If you have 16 ounces, 12 ounces, whatever, of hot tea, and you're like heating up like a little bit of thin metal, it's not that much. Okay. Why does a nuclear bomb explode violently but a nuclear reactor releases energy in a controlled way? Discuss. Why don't nuclear reactors blow up? Yeah, sure. Well, for different reasons. I like fully contact reactor. Yes, fully contact reactor, right. But why? So how does a nuclear reactor get energy? But what is the underlying physical principle by which a nuclear reactor is like, how can a nuclear reactor even make any energy? What? Okay, so you mean like, as heat? Like heat things up? That's true. Where does energy come from in a nuclear reactor? All right, y'all, I'm going to give you a signpost or a discussion. I'm going to pin a discussion thread or something. How does a nuclear reactor even make energy? Like, by what fundamental principles does a nuclear reactor create energy and not just eat up energy? This is a group discussion. Talk about it with your friends. Just trying to like aim the discussion. Okay, what is fission? Yeah. So what is fission? Okay. So hey everybody, we're going to talk for a sec. So kind of that question that was just posed, how does a nuclear reactor create energy? Right, some of the words that were said were uranium, fission, explodes, neutron. These are all words that are correct in this discussion, right? I don't know kind of where the various discussions where we were kind of talking about like what happens when uranium undergoes fission or any element undergoes fission, right? That would be a very important concept to know is what do we mean when we say what happens when uranium undergoes fission? Like what, explain like in 5 terms, what is going on, right? If you can't do that, that would be an important thing to be able to do. Continue discussion. Okay, so, right, uranium splits into two things. Why does energy come out of that? It's actually not as complicated as I think. Well, no, not quite. Okay, suppose that my uranium splits into 2 smaller elements. If I were to weigh those 2 elements and then weigh the uranium, these 2 elements added up, their weight is less than the uranium. Right, that extra mass, that extra weight, got turned into energy via this E equals mc squared. Right, so when I take a big thing that gets now, also energy comes shooting out because what's left over weighs less than I started with. That extra difference in weight, mass, not different. And true neutrons go flying out. When they chain reaction, neutrons go flying out and hit other uranium and make them split. So you have all these other photons and neutrons shooting out. You get the chain reaction of explosion. And that energy in a nuclear reactor, if you boil water, you turn a fan, you turn a yeah, the fission fragments are less massive than the original uranium atom, and the coefficient energy, the difference in mass, has to get made up by energy difference. What's up, dog? When what? When it decays or when it goes fission? So fission is usually when a neutron smacks into something and makes it. It depends, I'm not 100% sure, but yeah, they undergo alpha, beta, and gamma decay. Yeah, during fission it's negated by neutron. Okay, everybody. I heard the word moderator up there. Good one. Right, so the difference between fission and fusion is fission. When uranium undergoes fission, uranium gets hit by a neutron, usually like a fast-traveling neutron or slow neutron. You know the difference, right? But uranium will split into 2 smaller elements. Sometimes called fission fragments. There's a lot of other, just in my mind, I just call it crap. A lot of crap comes flying out. A bunch of neutrons, smaller, lower atomic number elements, and energy comes out. That's how this thing runs. But like, why does energy come out? Right? People are like, okay, on the count of go, just start saying like a few word phrases as to why energy comes out. Why does energy come out when uranium undergoes fission? Energy, okay. I heard energy. Something else, go. Okay, finding energy, great, even better. Keep saying words. Oh, the energy that keeps them together is now freed up. I like that. Okay, so yes, okay, sure, yeah, a lot of good things going on here. In my mind, the easy way to remember this thing is if I were to take all the fission fragments and put them on a scale, the scale shows a less than if I were to weigh just the uranium. Right? There's a difference in mass between what the uranium weighs and how much all the crap that came out weighs. All the crap that came out weighs less. Right? There's a concentration of energy. That difference in mass had to go somewhere, and via this E equals mc squared thing, this extra energy comes from that makes up that extra difference of mass, and so the energy can be conserved. Right? If energy didn't come out when uranium underwent fission, we wouldn't have nuclear reactors. Right? It's that difference in mass that uranium weighs more than all the junk that comes flying out. That's why we have nuclear reactors. Blink if you understand. Nice. Okay, okay. So now why does a nuclear bomb explode violently, but a nuclear reactor releases energy in a controlled way? Start shouting out things. Yeah, but that's just, okay, control rods, moderators, what do those do? So one of the, okay, so let me direct this way. One of the fission fragments that comes flying out when a uranium atom gets hit by a neutron, some neutrons come flying out. If there's other uranium around, could this be good or bad? No, both. Right? So what does a moderator do? Absorbs, that's a good word. Slows down, sure. There's like another word in here that like regulates, sure, but like what are we regulating? Neutrons. Yes, we are decreasing the balls that got dropped in the mousetrap thing. We're like removing some of the balls with this moderator. We're making the balls not. We're taking some of the balls out of the thing. Like we're catching them in the air before they have a chance to hit more mousetraps and let more balls go. Right? If we catch them all, no more mousetraps go off. Right? If we catch all but one, like one mousetrap goes off. If we don't catch any, all the mousetraps go off. All the mousetraps going off is bad.
Moderators don't absorb neutrons; they slow them.
Oh, okay, sure. Aren't there both in control rods? Yeah, okay, so control rods absorb and moderate. So I'm being corrected by the nuclear engineers in here. Absorbers absorb, moderators slow down. Any questions? So control rods don't have absorbers, or are not moderators. Okay, I'm feeling good about this. The point is that moderators and absorbers slow down the chain reaction. They catch balls inside the box of mousetraps, or they slow down the balls inside the box of mousetraps so that fewer mousetraps go off. Anyone know what I'm talking about when I say the box of mousetraps? What? Who said no? I'm just kidding. If you didn't watch the lecture, there's a lecture on nuclear reactions where there's a demo where Professor Soller dropped one bouncy ball into a big box of mousetraps loaded with bouncy balls. And when one bouncy ball hit one mousetrap, that bouncy ball went off, and all the bouncy balls, all the bouncy balls, and the whole thing went off. What's up? It's fine. I got it. Yeah. No. Did you hear that?
Sorry, so the question is, what's the point of the absorber or moderator?
Like, so notice way down here, the reactor only has 4% U-235. That's uranium with 235 protons and neutrons.
That's the good stuff.
Yeah, that's the good stuff. A bomb has 80% uranium is enriched with U-235. So why is there such a difference? Like, why do you need moderators and absorbers when the percentage in reaction is already low enough? I yield the floor to nuclear engineers.
Yeah, so you can think of it, U-235 is like the good stuff, right? So you have, so when you moderate, moderating or slowing down neutrons makes it, the U-235, it's easier for it to absorb it and fission. So slow neutrons equals more fissions than U-235. So reactors don't have much of the good stuff, or U-235. So you need to help them along a little bit with this moderator to make it easier to absorb it. Nuclear weapons have a whole bunch of this stuff that wants to explode very quickly, right? So then you don't need all this fancy other stuff. You can just slam it and then it explodes. Yeah, so I think the major difference that you can think about a nuclear reactor versus a nuclear weapon. So a nuclear weapon, for every little tiny increment of time, you have more and more fissions. So the energy release goes up really, really fast. Whereas in a reactor, you don't want that. You want it to be constant because you're connected to the power grid. So you don't want it to be wobbling or anything. You don't want it to be exploding, obviously. So you want it to stay constant. So the number of reactions per second in a bomb always increases, whereas in a reactor stays constant. Cool? So the question was like, why is this percentage low enough that you never have to worry about a chain reaction getting out of control? And the thing is, you do need to drop the control rod sometimes because the chain reaction will grow if you don't do so. However, it will not grow at the speed that's required to release the power of a bomb. And that's, is that what you were asking? Yeah, okay.
Okay, thanks.
So that's what Sasha was talking about with these like time intervals between fission events-ish.
Yeah. Other questions? All right.
Okay. We're going to skip a few of these. Really quickly, because I'm tight. This last one, explain why some types of guns have more recoil than others. Not some types, something like design, but like, why do some guns recoil more than other guns? You have 30 seconds to talk about your neighbor.